Okay, so we need to find the derivative of negative 7 divided by 2t minus 3 squared. So we've got a quotient rule. Do you all see that we've got quotient rule going on here? Mm-hmm. Yes. But we also have the chain rule going to be happening.
Okay, I think that's my problem. Is I tried doing like 2 equations at once.
Okay. So what we're going to have to do is when we take the derivative of the denominator, the derivative is going to have, we're going to use the chain rule. Okay? So we're going to take it slow. So the numerator is negative 7. The derivative of negative 7 is 0. So g prime of t is going to be 0. Do I have to put anything else behind it? Do you still want me to put the denominator? Anybody want the denominator?
No.
Okay. Okay, minus the numerator times the derivative of the denominator. So minus a negative 7, so plus 7. But it's only plus because it's minus a negative, right? Now we need the derivative of the denominator. That's going to be chain. So the outside function is like the x squared. Yes? So that's going to be 2 times the inside. And then 2 minus 1 is 1. Times the derivative of the inside. Two minus 3, derivative.
So 2.
2.
2, I mean.
Okay. All over the denominator squared. So it's going to be 2t minus 3 to the what? 4th.
Why is it 4, not 3?
Because you square it. On the quotient rule, you square the denominator, and it's already squared. Okay, so what I got? 7 times 2 times 2, so 28. Yes? So you have 28 2t minus 3 over 2t minus 3 to the 4th. And I can reduce a 2t minus 3. So 1 here, and this goes to a 3. So g prime of t equals 28 over 2t minus 3 cubed. Remember yesterday when I said you're going to have to put them all together? You're going to have to put them all together. No. It's baptism by fire. Yes?
With the 7 to the 2, that's the chain rule? Just right there?
This is the chain rule right here. The 7 is the numerator.
Okay.
Everyone good? Ainsley good?
How'd you get the 2 in front in the box? One of them
Because
is from the square.
this is only for, so that 2 is this.
Why are there 2 of them?
Because you have the derivative of the outside, so that's 2 the inside, and then times the derivative of the inside, which would be 2.
Okay.
Okay? Anything else?
Nope.
Okay. So f of x all I got for you are examples. That's all we got, okay? Because there's infinitely many options I could throw at you.
I would not do both of the rules like that. I would kind of do one and then the other. That's kind of my problem.
You got to be able to like smush them together. Okay, so that square root is a function with a function in it, yes? So we have a product and a chain going to happen here. Because the first equation is here. Not function, I should say. And the second function is here. And this has a function in a function. Don't follow. We need to rewrite this, though, before we start. As x squared 1 minus x squared to the what? 1/2. You can't work with the square root. By now you should know that, correct? So product says derivative of the first times the second plus the first times the derivative of the second, right? So f prime, give yourself plenty of room to write things out. So derivative of x squared is 2x. Then just times this 1 minus x squared to the 1/2. Plus the first equation, x squared, times the derivative of this. And this is where we're going to have to use our chain. Because the outside is to the 1/2, correct? And then we have to find the derivative of the inside. So we bring in 1/2 in front. And this is why I put square brackets, to know that I'm doing like another derivative rule inside 1. So it would be what? 1/2. And then just write down what's inside. And 1/2 minus 1 is negative 1/2 times the derivative of the inside. No. Negative 2x. Okay, so we've done the calculus. Now we have to do algebra gymnastics.
Wait, how did we get negative 1/2 when we do that?
Minus 1. The basic derivative rule.
Oh, yeah, never mind.
Okay, don't forget about that. Don't like...
Well, I was just like, why are we getting
Yep.
negative 1/2?
Okay, so let's see. What can we do?
Nothing. I say we leave it.
No, I don't.
Go to sleep.
What about 1/2 and negative 2? Not just 1?
Yeah.
Half of 2 is 1?
Yeah.
Okay, well, the negative we're going to pull out front. So we don't forget about it. Because it's all multiplication, correct? So this 2 and this are going to go to 1, so we're good there. Well, that gives me x to the 3rd then, doesn't it? Yeah. So I have 2x, 1 minus x squared to the 1/2 minus x cubed times 1 minus x squared to the negative 1/2. So there's a problem with what's going on here. What is it?
The half needs to go to the bottom.
That negative needs to go to the bottom. But I have 2 terms, and I can't just move it to the bottom, can I?
No.
No.
I would. You should factor.
You got to do some factoring. So we need to factor out what we want to move to the bottom. So we want to move... Well, they both have an x in common, yes? Okay, so we should factor that out, right? Oh, come on, Pin. So I have an x in common. And then I want to factor out 1 minus x squared to the negative 1/2. Because I need that negative 1/2 out of there so I can move it to the denominator, right? Okay, so if I divide 2x by x, I get what? 2. Now remember, yesterday we talked about it. Factoring is dividing. And when we divide exponents, we subtract. Yes? And when you subtract a negative, you get a positive.
Wouldn't it just be 2 minus x squared?
Well, it would be, you're going to add, my pen is just not working. Okay, so we're actually multiplying through by that to the 1/2. Yes? Because we're subtracting a negative, which makes it a positive. Okay, so 1/2 and a 1/2 is 1. So I get 1 minus x squared. Is that what you were trying to say? Because I don't think you said this squared. Okay. So then I need to come to this. So I took out an x, so that gives me minus x squared. Well, then if I have the quantity to the 1/2 and the quantity to the negative 1/2, that gives me to the 0, which is 1. So that's all just collapses to x squared. Because when I distribute this to here, I'd have negative 1/2 plus 1/2, which would be 0, and anything to the 0 is?
I thought we were doing the bottom one.
There isn't a bottom one.
Wait, I thought we were taking out an x minus 1, x squared, 1.
Yeah.
We are.
That's where I'm at.
Okay, again, we are factoring. What is factoring?
Spreading it apart and distributing.
Yeah, but what math is, it's division. Factoring is division. Yes?
Yeah.
Okay, so when I divide exponents, I subtract them.
Okay, you gotta tell me that.
I did tell you that. Like 4 times.
I kept thinking I was dividing,
Okay,
so I was like,
so
what
you
is
are.
it?
So we're taking this, we're dividing by that, but you're dividing a negative, so it makes it a positive.
That was really complicated for us.
Yes. So now we distribute this too. And we need to move this
To the bottom.
to the denominator. So I have x, and then I'm going to have 1 minus x squared to the 1/2. And then when I distribute this, I get 2 minus x squared minus x squared. So what have I got there?
2 minus 2x squared.
2 minus 2x squared.
You ever wonder who comes up with the rules and how to? I've been watching this. I'm like,
Someone
who
who's
comes
crazy.
up with this?
Wait, why does the x not go down with them?
I don't know what that was.
Because the x doesn't have a negative exponent.
Oh, yeah, I guess. I thought it was just one combined thing.
Okay, so if I factored out an x, I probably should factor out a what?
2.
2. So I have 2x, and then 1 minus x squared. All over 1 minus x squared to the 1/2. But you should be having a conflict with what that is.
Wait, why isn't it?
Okay, what?
Okay, when you
I was freaking out there for a
distributed the 2, you didn't do anything to the x squared in the parentheses.
I took out the 2.
But you were distributing 2 to 1, which equaled 2, and then 2 to x squared.
Oh, I see what you're saying. I didn't distribute this. We distributed it and didn't do this. Correct? Found a mistake. So that's not this. What would this be then?
It would be 2
Minus
3x squared.
3x squared. Oh, then we wouldn't have to do this last step. Would we?
No,
Nope.
'cause you can't factor it out.
Now, if I was putting that in the computer, I'm pretty sure they would make you put it like that. But I'm not positive. You can try to leave it to the 1/2. Where it's a whole, where,
Every time I've done it, like putting it in like that, it would say it's wrong, and then I would just switch it over to.
okay, but is that one thing in a square root or a whole, like, function? Either one?
Yeah.
Okay. So square roots, they want you to put back in.
No,
No? She said it was okay.
I'm just saying, no. Not doing all that.
I thought you were very.
I can do the calculus part,
The
and
rest.
then I get confused
Okay.
halfway through.
Okay, so we just
I
have to
think I-
keep working on the algebra part because
I just
we
add random things together, and then I keep things together.
okay. So we need to keep working on that because of the fact is you are going to have to continue to find the derivative. Like you're going to have to find when we graph, you have to find the first derivative to find critical values. You have to find the second derivative to find points of inflection. And so you do not, and you can lie to me all you want, you do not want to find the derivative of that before you simplify it. You don't. Now, you may be okay like right here doing it, but you don't want to do it up here. You'd never get it accomplished. So we have to learn how to simplify. And the only way we're going to learn is how to simplify is what? Practice. See, look at all these. Oh, we got sine, cosines, change rules.
Wait, there wasn't anything under that, right?
No,
Okay.
no, I erased it. Remember, we erased it.
No, I'm talking like denominator. Yeah, that. I need it. We're done. Okay, I'm good.
Well, I've got more examples. I mean, that's what I have. If you don't want to do them, we don't have to do them. You need those. Okay, remember u is the inside function. So if we have sine of u, meaning 6x, anything other than just x, it is the sine of the derivative of sine, which is what? Cosine times the derivative of the inside. It is the same exact rule, guys. Because on cosine, the derivative of cosine is negative sine. And then the derivative of what's inside. So those are your trig rules.
So they're basically the other functions except in parentheses and then u to the derivative.
Yeah, because it's the chain rule. It's the derivative of the outside times the derivative of the inside. They just wrote them out. Yes, it is this, it's the derivative rules that you already have, but then times the derivative of the inside function. You're good. Cadence, let me know when you're good. Okay. So, want to do one? Or you want to go back to these
No, these,
fun ones?
no.
No? Cadence, you're such a party pooper. Okay, find the derivative of sine of 2x. So, derivative of sine is, so it's cosine of 2x times the derivative of the inside, which is 2x, which is 2. Can I just write it in the front? Okay, what's the derivative of tangent? Secant squared. So I have secant squared of 3x, and I left a space in the front. What's the derivative of 3x? 3. So the derivative of cosine of x minus 1. You guys do this one on your own, because I want to do the next one with you. Try this one on your own. It's negative sine of x minus 1. Do you guys get that?
Yeah.
Good job.
Well, I put my one in front, but
Well,
don't need it.
you're right. Okay, so remember when the cube is on the sign, it's like, it's really like that, yes? Yes? So now I've got a function in a function in a function. So I'm going to have to use the chain how many times? 3. So the outside function is what?
1/3.
Nope.
3.
The cubed.
2.
Yes?
3.
So that's 3. The inside. squared. So what's the next function? The sine of 4t, right? So then I get cosine of 4t. And what's the next? 4t, so I get 4. So now it's all multiplication, right? So 3 times 4 is 12. And we're going to have, well, this is sine squared of 4t, right? Times cosine of 4t. Did I count for everything? Okay.
No, I did it 3 times.
We did. 1, 2, 3.
Can't you take a 4 out?
No, nope. Okay, sine, sine and cosine are functions, they're operations, yes. It's like you can't factor out of a square root.
Wait, is this still the chain rule?
Yeah.
Okay, that makes a lot more sense.
That's why I said we have to do the chain rule 3 times, Jaden. Are you awake today?
I was thinking of the project one.
No, the chain.
We have to like have a quiz over these or something.
Yes, we will.
I think we should.
Okay, do you want to do either of these
No,
two?
no.
Okay.